Welcome, everybody. Good morning, good afternoon. Thank you very much for joining us. We are going to be talking about the road to net zero today. One of the strategies, of course, being detecting, pinpointing, and quantifying fugitive emissions. With that, let me introduce our moderators and speakers. So, of course, myself, my name is Mike Ellen. I'm Vice President Business Development with CR Wall. I am officially 30 plus years in this wonderful gas industry this past October. And I've been largely in product development most of my career until joining CR Wall about 7 years ago. I'm based in Calgary. I'm a father of 5 and grandpa to 2. Al Hemon is our manager of gas detection here at CR Wall, one of our subject matter experts. Al's got 23 plus years experience in this industry. He has worked in just about every facet of the gas detection, leak detection, supply chain, value chain, if you will. And we're really happy to have Al here. With Al, we have Roy Montemarano, and Roy is based in Houston. He's with Heath Consultants, and Roy's got 42 years of experience. So between these two guys, there's 65 years of gas and leak detection experience. Roy is certainly one of our guest subject matter experts and is here to help answer questions as well. Heath is a manufacturer distributor of gas and leak detection products. So with that, Al, I am going to turn it over to you. Just a quick housekeeping note here, guys. Everyone, I encourage you to use the chat and Q&A functions here in the Zoom meeting platform. I'll be moderating those, and we'll be taking any type of questions, comments, real time. So please, this is an educational event, and we encourage your participation. So do not hesitate. So with that, Al, thank you. Take it away.
Good morning and good afternoon, everyone. So just a quick overview of the agenda. We will be discussing overview of Canadian regulations for fugitive emissions, introduction to leak detection, pinpointing and quantification, best practices for leak survey, some common sources of fugitive emissions in gas systems, and what are the new drivers beyond safety. I'll be discussing method 21, conventional and modern screening methods, challenges, new approaches and best practices, overview available solutions for leak survey and quantification, and selecting the best technology for your application. And then we'll look at highlights and key takeaways. So what is net zero? Net zero is achieving a balance between the carbon emitted into the atmosphere and the carbon removed from it. When it comes to Canadian regulations for fugitive emissions and greenhouse gases, so what has the Canadian government already done? It has established federal regulations reduce methane emissions by 40 to 45% by 2025. Clean fuel regulations with reduced carbon intensity and emissions from oil and gas production. $750 million emissions reduction fund has been put in place. Energy Innovations Program, EIP, so Canadian Emissions Reduction Innovation Network to accelerate development and validation, and deployment of clean technologies. Investments in tax credit for capital investment in carbon capture, utilization, and storage. Some emission sources, common emission sources, so for fugitive leaks, so implementation of leak detection and repair LDAR program to identify and minimize hydrocarbon gas leaks. Inspections of leaks 3 times per year. This is typical. An alternative LDAR program is possible. So alternate leak detection methods may be used if it is demonstrated that the emissions reductions are equivalent to the reductions that would be achieved with the required inspection program. Some corrective actions when leaks are larger than 500 ppm are found. And this all came into force January 1st, 2020. So venting from compressors. For compressors with a rated brake power of bigger than 75 kilowatt and operated at least 5% of the time over the last 3 years. Vent gas from seals or rod packings and distance pieces must be either captured to be conserved or destroyed, or vented and measured annually continuously. Corrective actions when emissions are higher than the applicable limit. And also this came into force January 1st, 2020. When we talk about venting from well completions for facilities located outside of British Columbia and Alberta with a gas to oil ratio of at least 53:1, there's no venting. Conservation of hydrocarbon gas for reuse on site or sale, or flaring, clean incineration of hydrocarbon gas. General facility production venting for facilities where the combined venting, destroyed and delivered hydrocarbon gas volume exceeds 40,000 cubic meters. Venting limit of 15,000 cubic meter of hydrocarbon gas per year. Conservation of hydrocarbon gas for reuse on site or for sale, or flaring, clean incineration of hydrocarbon gas. This will be enforced as of January 1st, 2023. Venting from pneumatic devices or controllers or pumps. If the combined volume of hydrocarbon gas pumped by all pumps is greater than 20 liter per day. Venting limits of 0.17 cubic meters of hydrocarbon gas per hour for pneumatic controllers. Conservation of hydrocarbon gas for reuse on site or for sale, replacement with non-emitting or low bleed for pneumatic controllers, or operate using a gas other than hydrocarbon gas for pneumatic pumps. This also came into effect January 1st, 2023. For other equipment, minimize emissions from pipes, hatches that are not required to be open, and sampling systems or pressure relief devices at the facility. This came to force as well January 1st, 2020. So some common sources of fugitive emissions: compressor unit valves, relief valves, unit blowdowns, compressor packing, meter tubes, valve stems and fittings, fuel valves, various piping and vessel flanges, threaded connections, online gas analyzers, and pipeline damage. What are some major causes or cases of gas leakage? So corrosion, construction material defect, third-party damage, human error, or mechanical failure. So what is the definition of leak detection, pinpointing, and quantification? So detection is identifying existence of a gas leak. Pinpointing is identifying the source of the gas leak or the actual position of the gas leak. Quantification, it's determination of concentration and or emission rates. So what are the reasons for conducting leak survey? It could be federal and provincial requirements, industry stakeholders, many stakeholder driving methods and practices. So AGA, CSA Z662, AER 60 directive, EPA, Method 21, TSA, and the list goes on. Reducing unaccounted for gas. System overview, budget funds where needed. So leak classification drives work and investment. Reduce operating costs, order complaints, callouts, and also public image. What are some of the new drivers for leak survey beyond safety? So public image is one. Third-party environmental oversight, watch groups, fence line investigations. focus on corporate environmental, social, and governance goals, improvement in technology, and new regulations and LDAR strategies. So method 21 AWP, which includes newer technology like an RMLD, remote methane leak detector, an optical gas imaging cameras, and AGA GFOs.
So Al, I just wanted to mention, and Roy, you probably have were possibly involved with this customer in the US, but there is considerable evidence now of third-party groups doing fence line investigations. So while there's tremendous technology out there, both with handheld laser detectors and optical gas imaging cameras, they're also being used by these environmental watch groups now, doing their drive-bys and fence line investigations. And so it's driving a lot more proactive leak survey work than might have otherwise been historically scheduled. Roy, you're seeing that quite a bit in the US now, aren't you?
Yes, we are. A lot of the watch groups are now going around. You have individuals even like Google going around in their vehicle testing for leaks throughout the atmosphere, just like the old advanced mobile leak detection devices. And now you got Google Earth.
So we can search where the closest gas leak is on Google.
And they're even doing that kind of a search. So yeah, we do have our little third-party guys going out there trying to find, trying to prove things. We even had guys going around, and one company, I won't mention, when they go around and find a leak, they actually mark it. What is like what do you call it? A little twist, connection and a zip tie. They mark it with a zip tie on a meter set. And so someone went around and took a whole bunch of pictures of these zip ties, and they said, oh, there's about 10,000 of them on running around. And they ended up giving this to the government in this particular state. And so they had a big news article and everything on it. So yeah, you got your individuals doing this stuff out there. And I mean, small little meter leaks, anything you can find on a meter set, it's a small little meter leak. It's nothing, nothing crazy, nothing that's gonna, cause any kind of harm. And they're going around saying, look at all the leaks look at all the, greenhouse gas emissions that you have going on here. Meanwhile, it's probably, it's probably, small.
Yeah.
But yeah, we have a bunch of them going around the country.
Wow. That's interesting.
Yeah. As far as method 21 goes, what's your the minimum regulation on that one? Is it 500 parts per million, or is it 10,000?
I believe it's 10,000.
Is it 10,000?
If I remember correctly. Yeah.
Okay.
So go ahead. Sorry, Ray.
Yeah, so the reason I asked is that we have one state that's actually gone down to 500.
Oh, really? Okay. That's very minute leaks.
They've actually gone down to 100, and they put it down to the fact that if you have, say, 1,000 to 9,999, you have to have it fixed in 5 days. And if it's higher than that, you may have to fix it in 2 days. And if it's higher than that, you got to have it fixed right away.
Wow, really? Okay.
So it will vary depending on where you are.
Yeah.
All right. Sorry to interrupt.
No, much appreciated. So when we talk about method 21, so there's conventional and modern screening methods. So what is method 21 inspection? So method 21 requires the use of a specialized VOC analyzer, so volatile organic compound. The analyzer must be portable, have a battery-powered sample pump, be certified intrinsically safe, and equipped with a sample probe. So when you're monitoring a component or a test point, the analyzer's probe tip must remain in contact with the component's potential leak areas. So how long does method 21 take, and how often must it be done? So method 21 inspections times vary with components or test points. type and size, and ranging from 15 seconds for small components to several minutes for larger ones. If an elevated reading is measured on a component, then the inspector must continue monitoring there for a longer period of time to ensure the concentration does not rise above the component's leak threshold. So an experienced Method 21 inspector is able to monitor between 250 and 450 valves per day on average. A typical refinery or chemical plant containing many thousands of valves, pumps, and connectors in VOC service requires a team of monitoring inspectors to complete the routine Method 21 monitoring on schedule. So is Method 21 effective? If it's done properly, Method 21 is very effective at identifying leaking components. Various factors combine, however, to make routine Method 21 leak detection ineffective. So various factors combine. So LDAR contractors work in a highly competitive market, resulting in low wages. That could be part of it. Low hiring standards and high turnover rates. Method 21 inspectors must work in a noise-filled, dangerous environment at elevated heights. This will be relevant when we talk about modern screening methods. The work is challenging, pay is low, and monitoring hundreds of components day after day quickly becomes monotonous as a result of LDAR Method 21. Programs are prone to significant monitoring inconsistencies. So is it really cost effective? In a typical refinery having more than 200,000 regulated components, a Method 21 LDAR program programs cost can easily exceed $1 million a year. Unfortunately, studies indicate that most of this money is spent monitoring components that are not necessarily leaking. So is there a better way? A cost-effective and efficient alternative to Method 21 is the use of IR and optical gas imaging cameras. OGIs are not best suited for small leak, so that's a downfall of that technology. So if we look at the two alternatives right now, so Method 21. So again, Method 21, you're using conventional flame ionization or catalytic oxidation, thermal conductivity, and now infrared sensors or infrared controlled interface polarization. So new Method 21, the alternative work practice, AWP, we're adding finally gas imaging cameras, so passive infrared type technology. We're adding illuminated infrared laser detectors or remote methane leak detectors. So this is considered active infrared, and spectrometers.
Now we're talking about Method 21. I mean, that's an EPA program, but we're talking about it because why? It drives a lot of practices and work definition here in Canada, correct?
Yes. Yeah, it's pretty much the standard as far. So Method 21 is the standard as far as the type of instruments and the spec around those instruments that are approved, as well as the actual method. So how you there's different guidelines when performing Method 21 that surrounds different types of leak points and how to approach them. Okay, so the main difference, if we look at these two, I guess Method 21 versus an alternative work practice. So conventional Method 21, we'll call it, right? So they're handheld monitors and they detect ppm levels of VOC. They'll detect up to 100% gas as well. If we look at the AWP, we're using optical gas imaging to detect visible image of VOC leaks. So this can be done at a remote distance versus conventional equipment where you're actually right at the leak source. There might be some weather limits for both of them. High rain, wind, and humidity. For cameras, for OGIs, definitely rain, fog, wind, and extreme cold.
Probably add snow to that last one as well, correct? Because of the background for the handheld laser devices.
Yes, so for laser devices, exactly, you need a nice reflective surface to get a proper reading with those devices. And as far as leak definition, so conventional equipment will measure, they say 500 to 10,000 ppm. That's a typical range for quantifying leaks, versus the optical gas imaging camera. It's a visual leak detection.
When one gives you concentrations and the other gives you potentially emissions rates as well, right?
Yes. So with the optical imaging cameras, it's going to be a visual. So you visually see the plume of gas leaking.
Mm-hmm.
But then in conjunction with software, you can actually quantify that leak as well. Okay, so concentration of the leak source. Now, this is the interesting part. So again, conventional, like your first responders, your gas detectors, CGIs, typically a maximum of 3 meters, and even then, that's a long probe, right? Typical probes are about 1.5 meters. So you have to be right at the leak source versus something like an optical gas imaging camera or an RMLD, remote methane leak detector. You can actually take measurements or see leaks at over 30 meters. Okay, so depending on the lens type, and for the laser-based type units, it's about 100 feet, if you want to talk feet. So you're doing it from a distance again. As far as accuracy, both are very accurate. So the conventional method, they're prone to technician errors and leak locating errors because, again, you're physically measuring at a leak. You don't want to absorb too much air into the sample you're taking because that dilutes the actual concentration. Versus, again, a camera, once you know how to operate it, you get very high accuracy as exact leak source can be seen. So it's a visual aspect. Okay. The problem, again, with OGIs or optical gas imaging cameras is it's very hard to get accuracy or to see small leaks. So anything below 1500 ppm might be problematic.
And
I have to get you a new chair.
yeah.
Oh, sorry, guys. It's squeaking. Yeah. So as far as efficiency, if we look at it, so if we're using the conventional gas surveyors, CGI type units, you'll most likely do 250 to 600 components per day or test points. With an OGI or an RMLD, you can do 5,000, 15,000 test points per day easily.
So Roy, you've had firsthand experience running these RMLDs, of course. Can you literally walk along and do your leak detection real time, or are you stopping and dwelling on assets and components? Or can you just describe that quickly?
Yeah, just to go back on some of the things that Al said about the camera, one of the drawbacks to it that you also mentioned is that if the temperature that's behind what you're trying to detect is at the same temperature in the atmosphere, that camera probably will not see what the leak is.
Right. So your gas and your ambient, that you need a differential then. Right.
Exactly. So whereas the RMLD will see that particular leak while you're scanning along the atmosphere itself. Again, when you're using the RMLD, it should be very methodical, very direct. Going to, you don't just take it and just wave it along like a big old wand. You're pretty much, going at a very slow motion, very direct type motion, very methodical, and taking your time and looking at the readings that you're getting. So that way with the instruments, depending on which one you're using, it can be taking the data down at the same time. If you're using the newer RMLDCS type unit, it will be taking data down at the same time. And also the GPS type accuracy too, that you need to know where approximately that leak is. So yeah, you want to take your time and you want to go into that. You don't want to
Thanks.
rush with it.
Thanks, Roy. Sorry, Al, I just wanted to clarify.
No, that's good clarification. So as far as costs, so higher, obviously the conventional method is higher due to increased time on site versus maybe using an OGI or a IR based type unit. You know, you could save 15–30%.
So it's the old OpEx versus CapEx debate.
Yeah.
Okay.
So again, so typical instrumentation that you'd be using for the conventional method 21, CGI unit, combustible gas indicators, like the GMI gas surveyor is a great example of that. And or like the DPIR from Heath, which has an onboard pump, both units, and you're drawing a sample to verify the actual leak concentration, not the leak rate. So newer technology, RMLD, so laser-based type detectors that you can take measurements at a distance, as well as the OGI type instrument, so optical gas imaging cameras. So AWP, I don't know if I mentioned that, but its definition is alternative work practice.
That's the evolution of the standard or conventional method 21.
Yeah, exactly.
And for our guests that haven't reviewed it, would encourage you to do so.
So some of the challenges, new approaches, best practices. So gas and leak detection culture, everyone is responsible for fugitive emissions reduction, mitigation, trend to leak quantification, increase focus on opportunistic leak detection versus planned scheduled work, AGA committee recommendations for gas field occupancy, driving new best practices, and also new technology like optical gas imaging and laser methane detectors, driving new practices and benefits.
Like, I just wanted to add to this, is that first point I find quite fascinating. It is a real shift in philosophy or culture or strategy, if you will, around gas detection. We're seeing our customers, like many of you guys that are attending, your companies are now looking at everyone as possible opportunities to capture leak detection information data in the field. So more equipment in the field, more people trained to do so. So this goes back to that opportunistic versus planned or scheduled work. When your teams are in the field now, even though it's not scheduled, you're doing a quick leak detection on the facilities potentially that you're working with or working on. So we've certainly seen that happen. Is that the same in the US, Roy?
Yep. Yes.
Yep. Okay.
Same thing. You need to take your time. Yep.
So for gas field occupancies, let's talk about emergency response, protecting employees, first responders, and the public. So prepared by the AGA operations section, Safety and Occupational Health Committee. August 2022 was the latest revision. Recommendations above and beyond existing regulations. Committee identified 78 fatalities from GFO explosions. Recommendations include use of handheld laser methane detection instrumentation to determine areas of exclusion before entering a structure, and new committee formed to evaluate all tech, including optical gas imaging.
So as it was explained to me in very simple terms, field technicians, customer service operations personnel are now doing a remote scan using OGI or laser handheld devices of the facility's envelope, various leak points, windows, looking for evidence of methane there before entering the building, because a lot of the standard practice is, walking up to Madame's house and ringing the doorbell and going in that way. Now there's a preliminary scan, and that's the recommendation that looks like they're coming. And will be widely adopted, we expect. That's what we're hearing.
Yep, especially first responders. I mean, it's kind of it's the rule of thumb moving forward, right? So they're investing in these laser-based type technology to be able to verify areas before entering, or even before approaching closer to that specific area. So
Yes, we're seeing this increase now in the United States also. With the increase of laser detection to perform this particular function. Yes.
Yeah. So some of the approaches or technology that's readily available in the market right now. So again, your typical CGI combustion gas indicators. Some of you already use these. So for example, like the GMI 500 series first responders, GMI GS 700s, also high flow samplers, as line remote, line active infrared. So RMLVCS as an example, and OGI, optical gas indicators, so cameras. There's also fixed options, so fixed gas detection, LEL detectors, open path IRs, and also optical cameras that are permanently mounted or fixed. So what is the difference between passive plume imaging, which would be the OGIs, versus active plume imaging? So for cameras, you're seeing the leak plume in real time. It expedites emission detection, simultaneously detect multiple sources. Some limitation, so qualitative, not quantitative. Requires radiance difference between gas and background. This is what we're talking about, temperature. Some units are not intrinsically safe and require hot work permit. User experience and expertise developed over time. Demonstrated fields of application. So all oil and gas facilities that emit VOCs, fugitive emissions, pipeline leak detection, and also these imaging cameras are used in aerial leak detection. So literally mounted on helicopters, airplanes, and now drones as well.
Mm-hmm.
As far as the laser-based type units, so you'll detect leaks fast. It's very easy to operate, expedites emission detection. It's portable and mobile. Built-in calibration and to adjust laser drift. So this is a good point. So there's actually built-in verification calibration in these units. Qualitative, not quantitative. Again, it is methane specific, requires a background within proximity to emission source. So this type of unit definitely requires some sort of reflective source, so the actual laser beam can bounce back to the unit to get a reading.
So if I'm doing overhead piping and I have nothing but blue sky behind me, that's not sufficient background. Is that correct?
As long as, well, it's going to bounce off the pipe and back to your RMLVCS.
Right. If I bounce off the pipe, but I need some type of background.
Yes.
Distinct background. And snow is not one of them.
Roy, maybe you can.
Yeah, let me comment on that a little. As Mike said, yes, the beam, the laser would be bouncing back off the pipe itself. That's true. However, you can scan that beam above and below that pipe. And yes, you may get what we call a negative background read to you, telling you, hey, you're outside the regulations of the instrument. It's just giving you what they call a not sufficient background indication. However, if there is a good leak there, even though you're not getting a sufficient background, you can detect a leak at that particular time. and it will give you an indication, even though you may still have a poor background.
Now, how about the snow question, Roy? Because this
Yeah, the
this is
snow.
where we live.
The snow basically is reflective, and we've seen on new snow, you have maybe more than 30 feet, you're having a problem, which would be about 100 feet, about 30 feet. So
So 30 meters, 100 feet.
30 minutes, less than 30 feet, normally when the snow starts to get a little bit dirtier, then you could start working with it. But on new snow, it has been a problem with reflection and background. Yes.
What about ice, Roy?
Same problem.
Same problem?
Reflective, yeah.
And water, of course, too, then.
Yes.
Yeah.
Yes.
Okay.
However, now, if there's a major leak there, you could
Yeah.
still see it.
Okay.
Okay.
Depends on the size of the leak.
Just
Yeah.
something to consider, though, the background is important and the temperature differential
Right.
on the OGIs. Yeah.
Right.
Yeah, and the RMLDCS, as an example, will show you the quality of the signal as well. So it gives you a good understanding if you are getting a good reflection point. So talking about the RMLDCS, so detection distance, typically up to 100 feet, base line of sight. So you need line of sight without having to get up close and personal. So this is a great way to measure for leaks at a distance. Okay.
And especially hard to access and safety issues, right?
For sure, yes. So no access areas, and just long distances, so you can actually cover a wide area in a much more efficient and quicker way than using conventional gas arrayers, as an example, or DPIRs.
So Roy, if I'm walking pipeline, what's my battery life on this?
You do have, with this particular battery, you're probably looking at 6 hours or more. It depends on usage. It's probably about 6 hours, no more than 8.
Yeah, and I believe it comes with a spare battery, Mike, so you
do
double
have a
up
spare
on that.
battery, so it
Yeah,
is quick to
swap in the
change.
field. Okay.
Yeah, very easy to swap in the field. Yes.
Yeah,
very
not
easy.
everybody's working a full 8-hour day using this thing.
No, because they're much more efficient at it. So, so the way it works is the actual, like, the beam size. So it's conical in shape, and typically would be about 22 inches at 100 feet. Okay, so it does get bigger at a distance. And one of the good features, again, it's got a built-in daily self-check. So you're guaranteed it is properly operating as well as accurate. It's got an internal data logging. And one of the great features as well, it's got onboard camera. So again, it becomes a visual aspect. Most of these types of instruments, they always come with an onboard laser that you're pointing that laser to the source you want to measure. In certain circumstances, you don't want to necessarily use that laser for safety purposes or whatnot, or it might not be as visual. So this one, the RMLDCS, has onboard camera where you can actually take a picture of what you're measuring, which is a very nice feature to have.
I can have GPS coordinates, picture, and the readings from that site.
Yes, exactly.
Nice.
Just to go back on that a little, Al.
Yep, go ahead.
The data logging is actually taking a reading every 1/10 of a second. So you.
Oh, really? Okay.
Yeah. So just to give you that information.
Wow. So that's a lot of data logging.
Yes, it is.
So here's an example. This is the older version of the RMLD. So we can see the difference, the advancement that Heat made, which is a very incredible, actually. So this is what the newer one looks like versus the older technology, but this is the principle behind it, right? So standing from one spot, you can measure different areas in a much quicker manner than actually physically going there, taking a measurement with your gas surveyors. So primarily tool and best practice approach for leak detection on components, tread fitting, connectors, flange, tube connectors, valve packings, unit unloaders. So you'll find small leaks the fastest, allowing operator to then view and isolate with a camera and record the event prior to quantifying it with maybe something like a high volume sampler. Here's another example. Okay, so again, real-time detection of methane leaks. From a nice distance, quicker identification and repair of leaks. You'll screen hundreds of components in an hour, literally, and screen inaccessible areas simply by viewing them. So again, if it's a no access type area, it might be a fenced in yard. There might be a dog there. There might be something. So at least with this type of unit, you can take a measurement off a meter or what you need to measure without accessing that yard. Another product that heat supplies NCR wall is called the DPIR. So that stands for Detect to Pack Infrared, which is a portable leak survey tool. It is the most advanced and accurate available. Okay. Some of the features. So you've got Bluetooth connectivity that you can connect to GPS units as an example. Provides S-gas readings along with GPS breadcrumb trails for walking surveys. It's got an onboard pump in conjunction with infrared sensor technology. The DPIR is much more effective at finding underground leaks than laser-based detectors because, again, it's drawing a sample. It's got a quick response time and specific to methane is key for productivity with walking surveys. More efficiency at finding leaks with zero sensitivities to other hydrocarbons and less chances of missing smaller leaks when walking. So again, this unit is specific to methane. So CGIs, so combustible gas indicators, example, GMI, 500 series, 700 series. They're fully customizable to your needs. The newest generation of this gas surveyor is the 700, which offers many options. So menus displayed on the actual display, sensor technology and gases being detected. So the newer generation, the GS700, now utilizes IR-based sensors versus the older gen, which utilizes combustion chambers. So you'll get a more stable and accurate reading out of the new gen. Operation of the unit itself is very simple. You get alarm points. Everything is very visual when there's alarm condition, and there's also an audible alarm on it. So first responders, contractors, and leak survey crews can utilize the GS series and the GT, which is a more, it's a unit, I guess a simplified unit for contractors to determine levels of methane and other hydrocarbons in ppm, LEL, and volume gas. And the new 700 series also offers onboard Bluetooth, onboard GPS. It's got a very nice large LCD display and uses IR sensor technology.
Well, just putting all this together, I might use RMLD or OGI to help identify a leak. And then I might bring in a DPIR or a GMI gas surveyor, for example, to help me pinpoint the exact source of that leak. And what else am I using it for?
Yeah, so to pinpoint the leak itself and to get a value on the concentration.
So a good measurement of concentration, right?
Yep. Yeah, and the DPIR is a good option as well. So because it's got a resolution of 1 ppm. So, and it does come with a bar hole probe as well with the kit. So that's a good option for pinpointing as well. So OGI is optical gas imaging cameras. So we can see here, this is an example when looking through the OpGal. OpGal manufactures an OGI camera. It's called the IC Gas, which is a great product. But these are some of the examples where you can actually see the plume of gas through the camera. Okay.
And it does quantification as well.
Yeah, so
Correct.
yeah, we'll talk about that next slide for
Okay.
sure. So the leaking gas temperature differs from the background temperature. That is important, right? So the camera needs that temperature difference to be able to see this type of plume. Okay, so the IC gas in this example camera, its spectral band coincides with the emissivity or absorbance spectra of the leaking gas. So the sensitivity.
In fact, you're about 13 minutes there. Al.
Okay, good. We'll go ahead here. So the IC gas produces an image of infrared energy and displays it on a screen, similar to how camcorder display videos, right? So very visual. So talking about quantification, so the OpGal, as an example, they do have a full suite of software for quantification that works in conjunction with the IC gas camera.
Right, so I can capture that information in the field with my handheld, bring it back into my facility, and then process it with the software for quantification. Is
Correct.
that how that works? Okay.
Correct. That's exactly how it works, and it works really well with my experience, the tests I've done in the past.
And also, just to let you know, I guess they just said that software is free.
Oh, really? Wow, that's great news. You still probably have to buy their tablet, but
No, you won't have to buy that tablet. I guess the software is free and it's supposed to be able to fit on any tablet now.
wow, that's a great update.
That I'd have to verify, but I heard that the software is free now.
Okay, yeah, because software is typically for that kind of suite of software, they're pretty pricey, but at the end of the day,
Yeah,
the cost of ownership is minimal.
And that's for your quantification. Yep.
Yep. So just a quick example here of different applications. So optical versus something like the RMLD CS or RMLD. Yeah, the CS is newer version. Facility commissioning. So both unit, yes, annual the IMM surveys, right? Open-ended lines. So optical seems to be better. Obviously, the RMLD, you need a backdrop. Yeah, so again, they both have some challenges depending on the application. So the next item that is used to quantify leaks up to 25 CFM. So this is quantifying the leak rate, not the concentration, more the leak rate.
So it's concentration by volume is what this does, right?
Yeah, exactly. So they're portable, intrinsically safe, battery powered units to determine a component's leak rate by sampling at high flow rate to capture all the gas leaking from the component along with certain amount of surrounding air. So by accurately measuring the flow rate of the sample stream and the natural gas concentration within the stream, the gas leak rate can be calculated using equation 1. So this is the type of equation if you were using something like the Simtech unit. I know more advanced units, they actually do that calculation. So you'll see your leak rate, you'll see your gas concentration, and then it's going to do this calculation to give you your actual leak size. Some of the benefits, so total capture measures leak rate directly, accuracy calculated. So typically it's plus minus 5% of reading. You can do 30 measurement points per hour typically, and a repair decision based on leak rate and repair costs.
So that's another trend too, really, isn't it? I mean, instead of the historical classifications driving all investment decisions and scheduling for repairs, we're seeing leak rate or concentration by volume being used more and more to drive investment decisions and scheduling for repair.
Yeah. So standard leak surveys, I mean, people actually walking lines and rural and those types of environments, they wouldn't necessarily use a high flow sampler. But for examples like you see this gentleman here, yes, it's a great option to for larger leaks, right? So large emission sources, higher than 6 CFM. So like mainline suction, discharge unit valves, blow down valves, pressure relief valves, rod packing, turbine compressor seals are great examples of utilization of this technology. What you see in this picture here is the gentleman from Heath is using a capture bag that is often used in conjunction with high flow samplers. There's other methods. I've seen all sorts of different ways of people wrapping around to be able to capture that leak.
You need to know the volume though, correct?
Yeah. So highlights and takeaways. So evolution of gas leak and leak detection culture. Everyone is responsible for emissions reduction and mitigation. Method 21, so CSA Z662, leak detection practices are evolving. Gas field occupancy, best practices driving use of remote methane detectors. There's trends towards increased quantification likely to continue. Right technology for right application, so more important than ever. What about drone, mobile? So all interesting options with laser methane detection and OGI technology options.
Any questions from our guests here? Don't hesitate. We've got some two very accomplished subject matter experts, so don't hesitate. Okay. It looks like we're good. I want to thank everybody again for attending. Good to have you here, and thank you again to our speaker Al and Roy for your support. We appreciate it greatly. And with that, everybody, I hope you have a super day, and thank you again.